All right, good afternoon, everybody. My name is Connor Johnston, and I'm going to go over my experiment with the hard-boiled egg for my Why Science Matters class. We're going to go over the ingredients first. So we got hard-boiled eggs. We got 3 of them. We got 2 Starbucks Frappuccino bottles, a small one and a large one. And then we have our test demo right here with some burnt paper and a hard-boiled egg inside. And then we have some canola oil and some paper towels with a soap with canola oil. So we're going to get one of these hard-boiled eggs into these Starbucks Frappuccino bottles. So what we're going to do is we're going to light these strips of paper on fire. Actually, before we get to that, we're going to demonstrate that you can't get these eggs into the bottle just by letting them sit or gently pushing them in. If you start pushing it inside, it starts to peel the egg away, so you can't do that. So what we're going to do is we're going to coat the inside rim of the Starbucks bottle with canola oil, lube it up. And then we're going to take our strip of paper. We're going to light it on fire. Put it in there. Didn't quite work. This is going to take a couple tries. There it goes. So that one went in pretty quick. One thing that I noticed is you have to let the piece of paper burn for a little bit longer. Then can't drop the egg in right away and then drop the paper in. You have to let the paper burn for a little bit before it goes in. Because if there's a really small flame, the egg won't go in all that well. And then we're going to demonstrate on the other bottle as well. This one's already been lubed up. So we're going to light this piece of paper. And there you get to see the egg vibrate on top of this Frappuccino bottle a little bit as the air inside rushed outside of the bottle. So the science behind the hard-boiled egg. Egg whites are made of water and proteins. Proteins are made of long chains of amino acids, but in an egg, that chains are clumped tightly together in individual spheres. These are called globular proteins. When the egg is heated, the proteins and water molecules begin to move faster. As they move and collide with each other, the individual protein chains start to unravel, eventually bonding loosely with other protein chains, forming a network of proteins with water trapped inside. The consistency has changed, but the runny egg from white to a soft solid. So how does the squishy but solid egg get mysteriously pushed inside the bottle? The answer is all about the pressure of the air. When you first set the egg on the bottle, the air pressure inside the bottle matched the air pressure outside, so nothing has happened. When you drop the burning paper through the neck of the bottle, it caused the air inside to heat up and expand rapidly. That expanding air pushed the egg aside and escaped from the bottle, which is why you saw the egg vibrating. You saw that here on the large Starbucks Frappuccino bottle. The egg, when the fire consumed all the oxygen inside the bottle, the flame went out and all the remaining air in the bottle cooled down. Cool air takes up less space, exerting less pressure inside the bottle. The egg acted as a seal to prevent the outside air from getting in to fill the extra space. The result was an unbalanced force. The force of the air pushing on the egg from outside the bottle was greater than the force of the air pushing up on it from inside the bottle. Voila, the egg was pushed into the bottle. I don't really think there's a real life practical use for this experiment other than demonstrating change in air pressure with oxygen being used by the fire. I picked this lab experiment because of the simple ingredient list and easy availability of all the resources needed to do the lab. I already had a lighter, I already had eggs, I already had canola oil. The only thing I needed to buy for this was Starbucks Frappuccino bottles. So this concludes my lab experiment. Thank you.